Hi, this is E.J. Daigle, Director of Robotics and Manufacturing again here at Dunwoody College Technology. I'm going to take you from where we were doing some relay logic circuits on the board here a little bit ago, and now I'm going to take you into an actual application. So we're going to try to wire up a relay control circuit. First of all, I'm going to start off with my wiring diagram that you can reference. We're going to start out at 24 volts, and in the lab we'll use red and black because that's what we use for all of our lab equipment. In industry we might use different color wiring, blue and white with a blue stripe. I'll start off at 24 volts DC. I'm going to pull a wire down to the stop push button. So I will come into here, into the Phoenix terminal. I'll make contact, and I will tighten down the termination. Okay, and we can see that the red wire is coming in the top, and now I've got a red wire coming out at the bottom. So there's 24 volts being fed to the panel, and now I'm going to feed 24 volts down to my stop push button. Stop push button is right here, and I'll be able to see that it's the stop push button by the contact on the back that says normally closed, NC, like we were talking about downstairs. Good idea at this point to trim up the wires. We want to try to keep our wires nice and neat and tidy. Want to make sure there's enough wire that we can open the panel, but not so much wire that we have a bowl full of spaghetti here. So I'll cut the wire down to a length that seems appropriate, strip the other end, and we'll bring this into our normally closed contact. Again, this normally closed contact is for the stop push button at this point. And we'll tighten that termination down. Okay. Now looking at my diagram, I see that the stop push button actually feeds straight to the start push button. So the nice thing about that is the stop push button's NC, the start push button's NO, so I have a start and I have a stop. I will be able to just jumper from one to the other without having to pull a wire all the way back or anything like that. So we'll take a wire and we'll cut it to length. We'll kind of size it up and see what we want for a length. We only need a small jumper wire. Strip us down. And it's worth mentioning that it would be fine, but for the purpose of time, we're going to just use wire. But a lot of times you may want to put a crimp connector or some sort of solderless connector on these to ensure quality of termination. But in our case, we're just going to strip the wires and go ahead and do it. Okay, so now I'm into my normally open, so I'm coming from 24 volts through the stop, through the normally open, and now looking at my diagram, the other side of the normally open goes over to my coil A1. Okay, so the other side of my start push button is going to go over to A1. So now this is a little trickier. We're going to be going a pretty good distance here. I see I've got to come through some conduit, so I can go ahead and pull my wire through this short run of conduit here and find out where A1 is on my contactor. So I can go ahead and make that termination. So now I'm in the A1 contact. That's the left side of my coil. And I'll make sure that I've got a little bit of slack here so we're not going to pull on the termination or anything. And then I'm going to try to kind of run wiring harnesses wherever I can. So I want to try to kind of run my wires in a similar fashion so that at the end I can put a zip tie around them and keep a nice neat bundle. So now I'm coming from that A1 back to the other side of my start push button. And if you're ever wiring to screw terminals, it's nice if you can wrap the wire around that screw in a direction that coincides with the direction you're turning the screw. That way you're actually tightening the wire onto the termination, vice doing something else, vice loosening the wire. Now looking back at my diagram, I can see that there's a holding contact in parallel with that start push button. So I need to come from each side of that start push button. The holding contact is going to, let's see here, it's going to go to, it's K1 normally open contact. It's going to go to the left side of A1, and it's going to go to the right side of the start push button. Again, I'm going to be working with all red wire at this point because this wire is all, at this point it's all considered hot or switched or live or whatever you want to call it. But I want to wire from these two sides of the start push button. So from one side, I want to go back to a normally open, and from the other side, I want to go back to a normally open. So there's a couple of wires we got to pull now. We can see that on our diagram. And it's a good idea, I'll come through from the other way. If you're having trouble getting through conduit, you can pull it through from either direction. It's a good idea to look at what side you're going to go to. If I'm going to use this normally open contact, which is the 13 and 14 normally open contact, in this case, I'm going to come through the top conduit because the 13 is on the top. The 14 is on the bottom, so that other wire, I might want to pull through the bottom conduit. And again, helps if we straighten our wire out. If you're running through a long piece of conduit or down a wall and having trouble, you may end up using something like a fish tape to actually pull a wire through there or push a wire through there and actually figure out a way to get that through there. Or in some cases, you can actually use other conductors, old conductors or other conductors to tie off to and pull. So I'm going to make a termination at terminal 13, which is one side of my auxiliary normally open contact. It's always a good idea to give it a little tug. Make sure you shouldn't have any exposed conductor sticking out of the termination. It should all be internal to the termination, and it should be nice and tight. And then I know this other side needs to go to one side of my normally open. Okay, now in this case, there's going to be 2 wires in this termination, so it'll take a little bit of work for us to do. But all of these terminals in here can handle 2 wires. And of course, I didn't get in there. Sometimes you may even pull them out. And make sure you have a good termination. The key to this is making sure you have a good termination. We don't want these wires to pull out at a later time. So once I'm nice and tight, I give it a little tug. If I can pull that panel, I'm probably pretty good. I'm going to come into the other side with this wire. Again, looking at our diagram, we can see that this contact is in parallel with that start push button. And this terminal is being a lot more friendly to me. Give it a little tug again. And then I want to make sure that I'm running these in a way that seems to make sense, so I'm not going to end up with a big bowl of spaghetti at the end. Okay, and I can see that 14 is going to come out here. And I'll come into 14. One of the things I'm noticing as I do this is I don't have a wire in A2 yet. And I know that that's going to have to be wired up. Looking at my diagram again, I can see that A2 is going to have to go back to my 0-volt common, or my negative. But my 14 is now in parallel. The normally open contact is now in parallel with that start push button. Now I need to pull a wire back on A2. Okay, so A2 is right here. This is where A2 is. That's the other side of the coil. In this case, this is going back to my negative or 0-volt. Again, because I'm coming from the bottom, I'm going to go through the bottom conduit. I don't want to go through the top conduit at this point. That would just take me further away from the termination. And sometimes that's going to be determined by things by like how full the box is, where you have room to enter the wire. But now A2, we know is going to go back to 0 volts, which is way back at the main panel here. This is my power distribution panel. And we'll tighten this guy up. And then we know he's going to go over to A2. So again, we'll make a nice, neat termination there. Trying to keep my wires all similar lengths and hopefully in such a manner that they can run inside of a zip tie or a wire harness. So A2 is in there now. Give it a little tug, make it look nice and neat. Make sure it's nice and tight. All my wires appear tight. We only have one set of wires left. We want to come through a normally open contact associated with this relay, and we want to go over to our buzzer. And our buzzer is internal to the panel here. So this will be the last set of terminations we need to make. But we do know that we need to come from power. So I'm going to go right back to my main power source with a red wire. And again, these Phoenix terminals have no problems handling multiple wires in them. And a little tug tells me it's nice and tight. I will run this through the conduit. Hopefully I get through, and I did. Okay. And this one I should run through the top. Because I'm going to use one of these other normally open contacts, if this is a motor starter, I'd be using L1, L2, L3 to supply a three-phase motor. In this case, I'm just going to use an L1, T1 contact. It's a normally open contact to supply my buzzer. So I'm going to run through the top because I want to go to the supply, which is L1. And again, trying to keep everything nice and neat and tidy. And we'll go into L1. Tighten up L1. That's again my other normally open contact, my other K1 normally open. We know that the 13-14 contact was one normally open. The L1-T1 is another normally open contact. And A1-A2 is our coil. So then we need to come out of there and we need to get over to the buzzer. Now this one's the one that's a little bit tricky because the buzzer's way over here. So we'll go ahead and strip a wire. We'll come out of T1, which will be right here. Tighten it up. Give it a little pull test. In this case, I'm going to go up and around trying to keep my wiring neat. This is the one wire that's going to run a little crazy. It's going to go over to my buzzer, which is way on the end over here, if you can see it or not. It's going to be the last two terminals. And the nice thing here is all these terminals are color-coded, so they make sense. So the red and black on the end here is going to be my buzzer. If I wasn't sure, I could always take a meter and do a quick continuity check and make sure that that's indeed my buzzer way over there. But I can see that it is. Plus I built these panels, so I kind of know that. And then the last connection is we need to supply the return on the buzzer. So we've supplied power through the contact to the buzzer. We need to return back to 0 volts. So we'll come through the top conduit. And again, it can get difficult when you get a few more wires in there. And you can try it from both sides if you need to. You won't always have this luxury out in industry. Sometimes a piece of conduit is very long and it may have bends in it. So it's not always this easy. But once you're through, then you know you've got it. We're going to come back into our 0 volts. Because this is going to be our return line for that buzzer. We'll get our return line installed. And as usual, we'll make sure it's nice and tight, and we'll give it a tug test to make sure it's good. And then that wire is going to come through to the second to the last termination, which is black on both sides of the Phoenix terminal. So you know it's in the right spot. You can see how I'm kind of measuring these up. I kind of measure them, figure out how they're going to lay, and then I give it a cut. And this will be my last wire. We'll make sure it's nice and going to make a good termination in there. Tighten it down. And give it a tug test, and we should be done. We'll go over this schematic some more, but let's give this a test. One of the things we could do at this point, we could do a bell test on it, make sure we don't have any shorts. A lot of different things we could try. But I'm going to go ahead and plug it in because I'm pretty sure. And the other thing we could do, and I'm not going to do this right now, is we could take zip ties, shorten wires if we needed to. We could put things into to wiring harnesses. And again, I might even shorten that wire up. I might take these wires going through the top and make a little bit of a harness. I can see I've got a little bit of a loop here. This wire is a little long. And I might harness some things together over here. But that would be a way to clean up your wires as you're done. But at this point, I'll close up the boxes. And what I want to do is I've got my DC power source over here set to 24 volts DC. So that's supplying power into this main panel. Now when I hit this button, if everything's working correctly, the start is going to give me my buzzer and the stop's going to take it away. And I don't have to hold start because there's a holding contact there. And the stop takes it away just as we described down in the theory room. And that is a basic relay logic control circuit.